Advanced Financial Modeling, Topic 1, Section 2. Estimating future returns using CAPM and global CAPM. In the prior topic, we took some data for 7 assets and computed the historical returns. In this topic, we'll now use the CAPM and global CAPM models. Future topics will use other models and techniques. So historical returns are unreliable predictors of future returns. So several widely used models are used to forecast future returns. We're going to cover them now. Specifically, CAPM and global CAPM. The next topic we'll cover Farmer French. So let's talk about the CAPM model. CAPM stands for Capital Asset Pricing Model. This model has a number of assumptions. Some of the important assumptions are the average or marginal investor in society holds a diversified market portfolio of all assets. An individual risky asset must provide a risk-free rate plus a risk premium. And the risk premium is the incremental risk that the investment adds to a diversified market portfolio. The measure of this risk is called beta. The formula for CAPM is the expected return of any asset I, we'll call that RI, is equal to the risk-free rate plus that measure of risk beta times the market risk premium. The risk-free rate is commonly a 10-year treasury or long-term risk-free rate of return. The market risk premium should be the expected return of the stock market in excess of your risk-free rate. Often, this is the S&P 500 is used as a proxy for the market portfolio. In practice, we use market risk premiums of about 3 to 7% based on historical returns based on the period you choose. Beta is going to be calculated using a regression. You're going to regress the excess returns of your security. When I say excess returns, the returns in excess of the risk-free rate. We're going to regress that as our Y variable against the return on the market. So looking at this little graphic here, what we see, each individual point, say this one right here, on this period of time, the return on security I was this level, and the return on the market was this level. So each one of those dots represents a discrete return in time. If we plot all the dots and then get the best fit line, using a regression analysis, the slope of that best fit line tells us our risk measure beta. It also is a measure of the sensitivity of the stock to the stock market. When beta is equal to 1, so the slope of this line is equal to 1, that says when the market is up, say 1%, your stock is up 1%. If beta is less than 1, that means your stock would have less than the risk of the market. So for example, if beta were 0.5, when the market's up 1%, your stock tends to be up only 0.5%. And if the market's down 1%, your stock is only down 0.5%. Beta is greater than 1 means that your stock is more sensitive to the market or riskier than the market. A beta of 2 means that if the market is up 1%, your stock could be expected to be up by 2%. In this example, we're also talking about global CAPM. The only difference between global CAPM and the normal CAPM, or what's sometimes called domestic CAPM, is the use of the market portfolio. If you consider the market portfolio, the S&P 500, we'll just call it CAPM. If we use a global market portfolio, we'll call it global CAPM. Global CAPM is appropriate if the average or marginal buyer of a particular security is globally diversified. So let's calculate the excess returns for our 7 assets right now. Changing over to Excel. These are the results from Section 1 of Topic 1, where we calculated the historical returns. We then calculated we used the monthly returns that we calculated. Now I want to get the monthly excess returns. So for the first month for Capital 1, I'm going to just take the monthly return in month 1 minus the Treasury bond rate, the monthly Treasury bond rate, which it looks like is an I-16. I'll hit enter. So that's the return of Capital 1 in month 1 minus the risk-free rate. Now I'm going to put a dollar sign in front of the I for the risk-free rate. The reason I want to do that is the risk-free rate is always going to be in column I. However, as I drag it across, it's going to stay in column I in this formula. So for example, when I copy it over to Walmart, the cell for O16, shift it to P16 by putting a $ in front of the I column reference. You'll notice that the I did not move to the next cell. However, when I drag this down, the row index for the risk-free rate will change. So notice this last calculation is 0.74, which is the last return of Capital One minus the last risk-free rate. Now I'll select this entire column. Copy. Let me go to the top. And I'll paste it across this top row. So now I have monthly excess returns for my 7 assets. I'm now going to calculate my CAPM model returns, but first I need to calculate the beta of each of the 7 assets. Now the beta, I could run a regression using data analysis, regression, and then look at the coefficient or the slope. However, if I just want the slope, I could just use the slope function equals slope, where the y variable is the excess return of the stock. So that's going to be my Capital One monthly excess return. Control Shift down, comma, my x variable, which would be the return on the S&P 500, which is proxied here by the SPY ETF. Control Shift down. Now notice, since I haven't closed this bracket, I could hit F4 now, function F4. That's going to automatically put $ in front of the row and column index of the market, the last cell reference my formula was highlighting. I'll close that because as I drag this formula across for the different assets, I want it to change from Capital One to Walmart, but I want to always reference the S&P 500. So there's my slope for Capital One, 1.167, my beta. That tells me it's a little riskier than the market. Walmart is much safer than the market, 0.31 beta. Now if I drag that across, what you see is the safest asset appears to be Walmart. The riskiest asset appears to be Capital One. And notice that the slope of the SPY to itself is 1, which makes sense. Now one more thing I like to calculate is I like to calculate the R squared of that regression. How much of the variability in Capital One's returns is explained by the market. Now I'm going to do a little trick. I know that the R squared has a function, RSQ, and has the same parameters. In other words, you put in the stock returns as the Y variable and the market returns as the X variable. I'm going to put a single quote in front of that cell, or in front of that formula, copy it down. I'm then going to remove that single quote, and I'm going to change the function name to RSQ. So there's the R squared of that regression. I'm going to try and change that into a %. So it looks like the market variation can explain 41% of Capital One's returns. Copy across, it only explains 4% of Walmart's returns, 1% of Brew's returns. Obviously, S&P explains 100% of itself, and then you can see the other R squares. I can now calculate the CAPM return. I'm going to zoom out a little bit. I'm going to assume the current risk-free rate using today's Treasury is 270. Notice if you click on that cell, looks like I have a cell reference there, RF. So if you click on any cell, cell inside Excel, you can type in a cell reference, say RF, enter. Now I can refer to that cell anywhere in my worksheet or any of the workbooks and just say my CAPM formula is going to be RF, which is going to reference that cell in K3, plus beta times, now I have another cell name set up for market risk premium. I'm going to assume that in the future, the stock market will give me 6.26% above Treasury bond rates, which has been the average from 1928 to 2018. I gave that a cell name of MRP. Notice how the cell darkens as I type it, or you can just type in, what's that, K4. Notice how now the formula has RF and MRP instead of referencing K3 and 4. These are also automatically anchored. So these are my CAPM returns. Notice that the stocks with the lowest betas have the lowest expected returns because those have the lowest risk. They add the lowest risk to a diversified portfolio. And now I'll repeat for global CAPM. I'm going to do that little trick again where I take a single quote, copy that formula, get rid of the single quote. Now the reason I'm doing the single quote is if I copy the formula, it's going to change the cell references for the references that aren't anchored with the dollar signs. Now I'm going to zoom out a little bit, and if I hit F2 or function F2, you can see the formula highlights the cells that are being used. So the slope of capital 1 relative to the SPY. Well, I just want to change SPY to the global S&P 500, IOO. Now notice that I can just simply slide the cell reference to IOO, and notice the formula will automatically change. I'll then hit enter. Now there are my betas of each asset relative to the global S&P 500 or S&P 100. I can then copy this formula, change that to R squared. And I can also see the percentage of variation explained by the global market. And then I can do my global CAPM return, risk-free rate, plus the global CAPM beta times the market risk premium, which is a named range. And there we have it. We have our CAPM returns, global CAPM returns, and these are, in theory, forward-looking expected returns based on historical measures of risk, a forward measure of the returns of the market minus the risk-free rate, and the current risk-free rate. By the way, the market risk premium, I have a reference to it right here. This is data from Aswath Damodaran from NYU. You can go to his webpage and get updated data. And these are S&P 500 returns from 1928 to 2018. And here's the Treasury rates, 1928 to 2018. These are the annual returns of the stock market over the Treasury bond rate. And I simply took an average of those from 1928 to 2018. And that's what I'm going to assume is my forward-looking market risk premium. However, I did also calculate based on T-bills. Another common way of doing CAPM is to use a risk-free rate of T-bills and not T-bonds. If I did that, I would change my regression to regress excess returns using T-bill rates. I also use my risk-free rate as a T-bill rate. So the bottom line is you can use T-bills or T-bonds, short-term or long-term risk-free rates for CAPM. The key is to be consistent. In other words, if you're going to use the long-term bond rate, make sure that is your risk-free rate in the CAPM formula, and also make sure that is the rate you subtract it from the market returns and the stock returns to compute the regression. So there are my results. By the way, I just have one graphic here. We're not going to recreate this, but I did graph the excess returns of Brew and the excess returns of the S&P 500. So each one of these data points represents a return of the stock and the return on the market at any given date. So for example, this observation right here, the market return was about, it looks like about 9. And that stock return looks like it's 15 to 20%. If we graph all of the monthly returns of the two stocks, these are all the blue dots. When I run my regression, the slope of that best fit line is right there in red. I'm sorry, the line is in red, and the slope would be the 1.167. So that's how another way I can interpret that slope or beta coefficient. Some advantages of using CAPM: it's theoretically appealing. In other words, the model makes a lot of sense. Every risky asset should at least give you the risk-free rate, otherwise you wouldn't buy it, and some compensation for risk. And if you assume that the marginal investor is, or a rational investor is diversified, that risk should be the risk related to a large diversified portfolio, which is beta. Another advantage is widely used in practice and requires few inputs. I need the current treasury, I need to calculate a beta, and I need a forward-looking market risk premium. Some disadvantages of using CAPM is the uncertainty in using market risk premium. If I look at different periods of time, say different 20-year periods for the last 80 or 100 years, you can get market risk premiums easily from 3 to 10%. Also, as we saw when we calculate our R-squared, the beta's explanatory power is often very weak. Also, betas change over time. So if I look at Walmart, for example, last year versus 2 years versus 3 years ago, you might get betas anywhere from very close to 0 to over 1. One thing that some practitioners do is they have read some studies or seen some studies that betas of firms as they mature tend to go to 1. In other words, as companies get more mature, they behave more like the overall market. Therefore, one thing called an adjusted beta is simply take the regression beta that we calculated, take 2/3 of that plus 1/3 of 1, and what it does is it pushes your beta towards 1. Also, another disadvantage of CAPM says the only risk factor that matters for stocks is beta, its sensitivity to the overall market. However, there have been persistent characteristics that have led to overperformance of stocks. For example, small cap stocks have tended to outperform large cap stocks over the long run, and stocks with high book value of equity over market value of equity have tended to outperform the others. So these two other risk factors have seemed to have been persistently leading to excess returns, and these weaknesses and particularly these two observations have led to other models like Farmer French we're going to mention in the future. Global CAPM. The justification for using global CAPM for domestic CAPM is if the marginal investor in a particular asset you believe is globally diversified, you should use global CAPM. However, still using your domestic risk-free rate. However, there is evidence to show that there's a home market bias in investing. Therefore, it's probably safe to use domestic CAPM for domestic equities. A technical note. In theory, you should always subtract the periodic risk-free rate from the market and the asset returns before computing your beta. However, you'll often find in practice it doesn't have much of an effect on, say, weekly and monthly returns, so some people will simply omit the risk-free rate for daily or weekly regression calculations. So in this topic, we calculated the expected returns of an asset using CAPM and the global CAPM model. In the next topic, we'll use another model called the Farmer French 3-factor model.